So for this next one, we're given the daily average cost in dollars per unit of electronics is given by C bar of X. And remember, C bar means average cost. That's what we're given here. And our parameter is that they have to produce more than 0. And X stands for the number of graphing calculators that Electra produces. Find the level of production that will minimize the average cost for this company and figure out what the minimum average cost actually is. So we're going to take the derivative here and set it equal to 0. So C bar prime of X is going to be 0.0002x minus 0.08. We're going to set that equal to 0. So if we solve for x, we add 0.08. We have 0.0002x equals 0.08. And divide by 0.002, our x value is 400. And so I have my endpoint. They have to produce more than 0. So the least they could produce is 0. And they're going to do more than that, is what they've already said. So if they plug in 0 here, my average cost is 40 into the original function. Compare that with my critical number is 400. And I don't have an upper bound to compare here. So that's unfortunate. When there's no upper endpoint, then we're going to have to make a sign chart anyway. So if I am missing endpoints, it's just like before. We need to make sign charts. But I could plug this in, see what the y value is. C of 400 when you plug into the original function is 24. But since I don't have an upper bound, I need to see, is that actually the absolute min, or is there possibly a min somewhere else? So I'm going to plug in my sign chart into the derivative. So it's kind of confusing. We just plugged into the original. But on sign charts, we always plug into the derivative. This 400 is special because it makes C bar 0. I can plug in anything to the left. Maybe I will plug in 1. So if I plug into the derivative here, 0.0002 minus 0.08, that's definitely going to be a negative number when I plug in 1 there. If you plug in anything after 400, maybe I'll just plug in 450. You would plug in, and 450 times 0.0002 minus 0.08, that's going to be a positive number. So I am decreasing and then increasing. So I definitely have a relative min here. And I just want to figure out, is it an absolute min? Well, let's compare it to the end behavior. So comparing my relative min to my absolute min, I'm looking at my end behavior, and on both sides it's going up. So this relative min is going to be the absolute lowest point. So this is my absolute min, which is exactly what I wanted because I'm trying to minimize cost this time, not maximize it. So there's my answer. They should produce 400 calculators for a min average cost. The minimum average cost for each calculator is $24. Here's my absolute min.